Okay. So the way this works, it's going to be a little trippy at first, but you're going to have a bunch of concentric circles. When I say concentric, what do you think that means? Same center. These are all circles with the center. It's called, you can think of this as the origin. Really, we call it the pole. This is the pole. So we'll talk about that in a moment, but what's happening is you have a bunch of circles that share the center. And the radius of varies. So it's radius of 1, 2, 3, 4. By the way, you don't have to have inner divisor for your radius. You could do a radius of 0.5 or 0.1 or 1/3 or 1.5. We'll talk about that later. Also, this is theta. So you can see like theta is like in different parts of the circle. We start here at 0. And what do you think is positive direction? Just as before. Counterclockwise positive direction. Right? And so that's pi over 2, pi, 3 pi over 2, 2 pi go backwards. So once we get into it, it'll make sense how this works. And it does have some tie into what we've done recently with all the trick stuff. Okay, so we'll come back to this in a moment. Let's go over here. So in this part, we'll become familiar with graphing points in the polar plane or polar coordinate system. We also will learn how to convert points in equation from rectangular form to polar form and vice versa. That is actually the tie-in, how this is very similar to what we've been doing recently with like the Pythagorean trig identity, like we had to convert, the equation of a conic section in terms of x and y into theta. Remember we did all that stuff? That's going to be pretty close to this stuff. First off, polar coordinate system. So it's a plane with point O, it's called the pole. So point O is right here. So that's called the pole, just so you know. And the polar axis, that line is called the polar axis, where theta equals 0. So we call it the polar axis. So it's horizontal. The graphical point of the polar coordinate plane, we stand at the pole. So imagine you're a miniature version of yourself. So I shrunk you on the board. You're standing right here and you're facing this direction. So, or if you took like maybe like a little like toy soldier, or I should actually brought to my house when I send my boys toy soldier everywhere. Put it here and you face towards 0. Okay, so that's how we start. So we stand at the pole, you're standing at the center, and you turn to face angle theta. And then walk out a distance of r along the terminal side of theta. If r is negative, walk backwards. Actually, that's a little confusing. Let's plot one first, and then see what's happening. That's a little confusing. So the way it works, that's always going to be r, and that's always going to be theta. And this right here is the pole. Let's switch colors. Let's go green. That's the polar axis. That's theta. And then this right here is r, the direct distance. Okay. A directed distance. Yeah, directed distance. That's what it says in my notes. It's the distance you travel. So here's the deal. If r is 2 and theta is pi over 6, so you want to locate a circle with a radius of 2. So this circle I'm tracing right now, we'll call that r equals 1. This one we'll call r equals 2. So that's r equals 2 on the outside. That's r equals 1
on the inside. And pi over 6, if I travel pi over 6, I'm over here. So when you graph it, really this is all you show. That purple dot. Let me draw it again. The purple dot is all you need to show.
Because if you think about it, is that purple dot on the circle to raise to 2? Is that pi over 6 along the circle? It is. That's all you did. So you're asked to plot 2 comma pi over 6. You're plotting that point right there.
These two actually, is it like each, like, grade mark actually two, or is it just a unit on the folder?
What do you know if this actually too?
Like, that point is actually, like,
Well, the distance from here to the pole is 2 for sure.
oh, okay.
Yeah, so guys, and actually I'm glad you brought that for clarification. The distance from that dot to the pole is 2. Because it's a radius. Anywhere on the circle, of course, will be 2. But where is it on the circle? This is at 0. It's kind of like a dial, right? You turn the dial to pi over 6. That's what you're doing. Or if you think about it, 30 degrees, it's like at 1 o'clock. Well, actually, technically, that's 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock. So if you want to use that, which we will do when we get the vectors later in the year, we'll talk about that. And we'll talk about what pilots actually talk about when they're talking about the coordinates when they're flying. But that's a I plot.
Okay. So that's going to be, so the purple dot here is 2 comma pi over 6. Now, what if r is negative? That could happen. If it's negative, I'm going to do this instead. Hold on. Let me zoom. Let me clear this. Let me do it one more time. 2 comma pi over 6 is right over here. Okay. Actually, switch colors for a bit of contrast. Let's go pink. So -2 comma pi over 6. So when it's negative, that's what says you walk backwards. You go in reverse.
So it's kind of like, hey, if you shrunk yourself, put yourself to a pole, it's okay, pi over 6. Oh, negative pi over 6. That makes sense. It's kind of like, okay, we'll use this here. Okay, so you see this little nozzle. Okay. So that's pi over 6, you turn around. Now it's pointing that way. So when it's negative, you just reverse 180. Just yeah.
So negative r, you reverse 180 degrees. Whereas negative r. So let's plot these points so you guys feel comfortable, and then we'll talk a little more about it. So a lot of it's kind of unicircle if you think about it. So 4 comma pi over 3. That would be a radius of 4. So 1. So 4. Usually I like to locate the angle first and then the circle. So 1, 2, 3, 4. That's point A. Would you guys agree? 1, 2, 3, 4. Yep. Okay, cool. All right, so that's so got that done.
Why is it done?
Oh, wait, I messed up, guys. I messed up. I did 4 pi over 3. There's a 4 comma pi over 3. My apologies. 4 comma pi over 3. You did the same thing. I know it was funny. I can't believe I did that. I was playing tricks on me. Sorry, my apologies for any confusion. Now do we agree about that? Yeah, your pi over 3 for your angle, 4 for the radius of your circle. Sorry, Charlie, go ahead.
I was, when I did it in Desmos.
Mhm.
Whenever I put in like
Mhm.
positive value, it automatically jumps to the top.
Hold on. Let's
So I
go.
Put in -2 pi over 6 as a point.
Well, hold on. If I do it like this, I'm gonna do parentheses 4 comma pi over 3 and label it. Oh. Oh, you know what it's doing? It's doing it as a rectangular. That's why it's not doing it as a polar. I have to figure out how we're gonna do it as a polar. It's actually being kind of what it's actually doing is it's technically graphing 4 comma 1.1 something on the XY plane. So I actually need to figure out how am I gonna do that. That's a little I wonder what's not doing as a was that what you're trying to do, Charlie?
Yeah, just whenever I typed in -2, 5, or 6, it sent it to the second quadrant.
Yeah, because that what it's doing is it's doing -2 comma 0.5 something. It's not doing pi over 6 as an angle. It's doing pi over 6 as a y coordinate. Like this is doing pi over 3 as a y coordinate. It's not treating it like r is 4 and theta is pi over 3. All we're doing right now is we're just let me look that up really fast how we're going to do that. But for now, just plot the points. So go and do the rest. I'll show you guys the answers in a moment. And I'm going to figure out how we're going to plot the bullet points.
Is it still negative 2 pi? It's the down.
Wait, that's exactly what I did. Select the yeah, insert a new expression line. Word pair. What? It's stupid. Well, oh, wait. Okay. Yeah, I got this.
Here's what you do, Charlie. I got you here. If you do, like, let's say we're going to plot 6 comma or -4 comma 4 pi over 3. So what you could do in Desmos, you say r, we'll talk about this when we get there, theta, comma r sine theta. And we'll say r equals, I'll also make a value 1, but we'll go from like -10 to 10, so we'll do a slider. And theta, we'll say equals -2 pi. We'll say equals 0. Sorry, thanks. Oh, actually, it doesn't like theta, so let's call it a. Wow, no slider. Here we go. Then we'll go from -2 pi to 2 pi. Yeah, so if I graph like 4 -4 pi over 3. Yeah, see, it puts a dot right there. We'll talk about when we get there. Or if we do 4 pi over 3 and -4, yeah, it does a dot right there. So we'll get there when we have a chance. Anyhow, let me show you guys the answers for this. Okay, hopefully you guys are getting it. So here we go. So for B, B is -2 comma 3 pi over 4. So 3 pi over 4 is over here, but because it's -2, you gotta go backwards. 3 comma -45 degrees. So -45 would be over here, raised to 3, so that's why C is right here.
3.5, that's interesting, so 7 pi over 6 is over here, but 3.5 is in between raised 3 and 4. So it's actually gonna be, you're gonna do it like that, so it's in between circles of raised 3 and 4. Negative 4 comma 4 pi over 3 is the same thing as a, by the way, a and e are the same. Because if you go 4 pi over 3, but then go negative 4, you reverse. 6 comma 210. Find 210, which is 7 pi over 6, right? And raised to 6 is right there. 11 pi over 6 is over here. The raised to 7, so 1, 2, 3, 4, 5, 6, 7, but it's negative, so 1/8. That's G right there. So we just about points A and E, they are the same. So that happens.
Once we get to the conversion between polar and rectangular coordinates, it'll make sense why algebraically A and E are the same. But no, this is a new system you're learning. It's kind of like a new language. So you're learning a new language a little bit. Are the other coordinates that would describe points A and E? Yes, they're infinite.
Like I could have said, for example, I said 4 comma 7 pi over 3. So 7 pi over 3, think about it. This is 7 pi over 3, 2 pi plus pi over 3, right? And go around, and pi over 3. Or could I have gone backwards? Negative 5 pi over 3? Yeah, and so make R4. Or make R negative 4, then we land at 4 pi over 3. You think an angle coterminal 4 pi over 3? So if I go around once, then it's not 4 pi, 4 pi, so that is negative 4 comma 10 pi over 3. It'll still be the same place.
Then you have to reverse after you land at 10 pi over 3. So there's infinite places where that can happen. What are two other values? I gave them right there. 4 comma 7 pi over 3 or negative 4 comma negative 2 pi over 3. Those work. There are infinite number of ways to describe a polar coordinate. Find all general ways to represent all polar coordinates for points B and C. So let's do that together. But again, what do you notice about points A and E? Same point. Are the coordinates? Yes, they're infinitely many, as it just said. Name two other points in the same location. Again, I said 4 comma 7 pi over 3. That's one example. Another example could be negative 4 comma negative 2 pi over 3. So infinite number of ways to describe a polar coordinate. Yeah, there are. So if you look at point B was negative 2 comma what was it again? 3 pi over 4. So you guys will probably remember doing this back in the day. How do you think I'm going to generalize this? Plus what? 2 pi k. There you go. Good. You guys remember. Or I can make r positive 2. But if I make r positive 2, what would be my new angle? 7 pi over 4 plus 2 pi k. Yep. See how this is all an extension of what we've done earlier with trig. For point C, let's switch colors for a bit of contrast. So point C, we're 3 comma negative 45 degrees. Usually I like to stick with radians, but we'll work with degrees here. It's okay. So I'll say 3 comma, but keep it in degrees, negative 45 degrees plus what? Yeah, 360k. Or if I put negative 3 for my r, so negative 45 is over here. So if I reverse 180, I'm at 135, right? Or just add 180. That works here. Subtract 180. I don't really care. Doesn't really matter. You didn't have to say 135. You could have said like 495 or negative 225. Doesn't really matter to me. It's all the same because k is an integer. So k can be positive or negative. Kingston, sorry, Kingston, go ahead.
For like every general like representation, can't you
Mhm.
just use like one of the Thetas and say plus pi to the third.
Yeah,
I think.
yeah, you could have two. It's just we want to just show that R could be positive or negative. Yeah, you can. Yeah, you could do pi k. Well, actually, no, you don't want to say pi k, but then you have to be mindful of R is positive or negative,
Okay.
right? So you actually do want to be careful of that. Let's take that back. Yeah, because I can't say 2 comma 3 pi over 4. Right. So I don't want to put pi because it didn't, because if you're at the other, if you're reverse 180, you have to share the negative R values. So, okay. So far, we're okay. Cool. All right, let's keep moving. Let's take a look at coordinate conversion. Okay, this is part that's more fun because it's actually more algebraic and it kind of ties what we've done recently. So now let's say you're to superimpose a polar coordinate system on top of the rectangular coordinate system. We get familiar relations R theta X and Y. These relationships will enable us to convert points, some equations from polar form to rectangular form and vice versa. So if I go back to Desmos again, notice we had like 4 pi over 3, common negative 4, it was right there. If you think about it,
What's a cosine of pi over 3? Guys remember the circle? How about the sine? Okay. And my raise is 4.
so if I were to just plot 2 comma 2 root 3, same place. See that red dot is right there.
What did I do? I took the radius, multiplied the cosine angle, and I took the radius multiplied by the sine angle. So we know this, right? We know cosine. If you think about, I draw a triangle here. That's a terrible marker. How long is that hypotenuse? That's 6 degrees. So how long is this side? How long is that side? All going back to geometry, right? Geometry. So if I plot 2 comma 2 root 3, it's the same thing as saying 4 comma pi over 3. The same thing.
I mean, here I had negative 4, not 4 pi over 3, but if I change that to 4, then make that pi over 3, there you go. Same thing. So that let's talk about that now. Okay, so generally speaking, we know this. We'll call this a right triangle. That's X, that's Y, that's R. So you would agree with this so far, right? And we'll call this theta, by the way. Would you also agree with this? Opposite or adjacent? Would you also agree that sine theta is X over R? No, I lied. Y over R, we're good. Cosine theta is what now? X over R, okay, cool. And also we could make some more statements. We could also say R is plus or minus root X squared plus Y squared. If we need to, we could do that. Also you could say X equals R cos theta. Y equals R sine theta. And if you substitute
R cos theta for X, R sine theta for Y. You get cosine squared plus sine squared, which we know is 1. So R squared times 1 equals R squared. So the Pythagorean trigonometry is satisfied there as well. So yeah, you know, all things we're pretty familiar with.
Yeah, Lucas.
Wait, on next unit's test, are you dividing these points?
Well, no, because no, I'll give you the conic section formulas.
No, like.
Oh, the polar.
Yeah.
Probably not.
Uh,
Because a lot of it's just knowing your basic trig. Yeah. Okay, so let's do some conversion. So it's pretty straightforward. X equals R cos theta. Y equals R sine theta. So when you convert, you're going to say 3 times cos of 5 pi over 6, comma 3 times sine 5 pi over 6. What's cosine 5 pi over 6? Unit circle, guys. Good. Negative √3/2. And next one, 1/2. So you could say that's negative 3√3 over 2, 3/2. Okay, go and try part B on your own. You guys got this. You just tell me what the x. So it's like an overlay. If I were to find the x and y coordinates for this polar coordinates, where would they, line up? Because 8 comma 7 pi over 4 is on a circle to the raised of 8 at a angle of 7 pi over 4, which by the way is in the fourth quadrant. So I would expect my x to be positive, my y to be negative. I would expect that. So it should be the same thing as saying 8 times cosine of 7 pi over 4. What's 7 pi over 4 cosine? And then sine. So it would just be 4√2 common negative 4√2. Which makes sense, because if I were to do a polar system and put over here, let's say it's a raised of 8. Awesome. So that's 8. But if I think about it, if that's 8, then this has to be 8 over √2. You guys remember the conversions? Oh, sorry, the 45, 45, 90 ratios, which is really 4√2, 4√2, or negative 4/2 because it's negative. So it all makes sense from a trig perspective. Okay, to go the other way around, let me clear this over here. So go the other way around. If you want to go from x, y to polar, if you think about it, -1, 1's over here. -3, 0's over here. What's going to be your radius here for part A? √2. What's your radius going to be for part B? Yeah, just call it 3. What's your theta here? Kind of just think about it. And we'll do in ratings, by the way. How do you think? How far have I rotated in terms of ratings from? What was that? Sorry. No, for this one.
3 pi over 4.
3 pi over 4, right?
Oh,
Yeah, remember, we're doing the standard way to new circle, going for the positive x-axis, going counterclockwise.
You're probably giving me maybe a reference angle, maybe? I don't know. How about that other one? Theta is just pi. Yep. So I thought you could just think about it. There's not really I mean, if you wanted to, you could say tan theta equals 0 over -3. If you want, you could do that. I'll just visualize it, because if you do the inverse tan of that, it's going to give you an answer between the negative pi over 2 and pi over 2. So I'll just look at it. So that's √2, 3 pi over 4. That's 3, pi. Yes, Lucas.
always have to be positive.
Not necessarily, no. But I did say so here.
Oh.
It did say so there. But I mean, remember, there's infinite possibilities, right? So, but because there's that condition, we had to go from 0 to 2 pi.
Why is R3 and not?
-3?
We could have made it negative, but it would have been 0 then. Because you want to land here. That's why. We're all in there.
Because the land there had to rotate pi. But if you put -3, then you have to put 0. Okay, let's keep moving. Okay, part C, another one here. Okay, that one's gonna be a little tricky. I know how much you guys love find the inverse trig with non-traditional unit circle stuff, because that was, I know, a little tricky for you guys. But 3, -4. Okay, we gotta figure out what theta is. Here's the problem. What's the calculator spit out when I throw it into the calculator?
Error.
No,
Should give an error.
inverse tan -4/3.
No, should be fine.
No, we're not doing inverse sine or inverse cosine. And I'll switch to radian mode. So inverse tan of -4/3. I get -0.927. Which means it's reporting the answer like this. Oh, there's a little typo here in the notes. Okay, that's fine. Sorry, my fill-up notes, there's a little typo there. So 0.927. What if I want to give the angle between 0 and 2 pi?
You add that to pi.
Yeah, exactly. If you do plus 2 pi to that, it should be 5.356. So my R value, by the way, isn't x squared plus y squared equal to r squared? So it's 5, 5.356. Which kind of makes sense. Well, obviously race is 5. If I drew a circle, because a terrible looking circle, that R value would be 5, and the angle would be 5.356. If you put 5 0.927, that's totally fine too, by the way. You've not been wrong. If you actually put this, that still works. But if I put a condition, which I did from 0 to 2 pi, then I want you to say this instead. Does that make sense? Because the calculator spits out an answer from -2 pi, sorry, -pi/2 pi/2 for inverse tan, but I have to adjust it by doing 2 pi plus that number, or 2 pi minus 0.927. Okay, how are we doing with time? Because we got some more time. Okay, so just so I don't confuse you guys too much, and I do want to talk about how this does tie to what we've been doing recently. Maybe get to page 5. I think we get to page 5. Okay, so we're on page 2 now. All right. So let's talk about more of the stuff. R equals 3, theta equals pi/4. What does that mean? Okay. Well, if R equals 3, then I want, so theta, so in this case, there's no condition, no condition for theta. So theta could be whatever. So how do you think I'm going to draw that? What do you guys think I should do? A radius. 3. That's it. That's your graph. Just a circle. That's it. So theta could be whatever. Clearly, that's a circle. With a center at the pole. Now here, there's no condition for R. Okay. So where's theta pi/4? So R can be whatever, right? So for example, R could be 1, R could be 2, could R be -1? R could be -3, -4. Like R could be really whatever. So in this case, I'm just going to draw that. So that's just a line. That's it. Just a line.
But of course, it's pass through pi over 4. So any R value with pi over 4 as its second coordinate in the polar coordinate system, this represents all the possible points. This line represents all possible points with a equals pi over 4. Because R could be whatever. We chose what we want. So
You have to kind of wrap your head around a little bit. It'll take some time because you guys have been trained for so many years to think in terms of X and Y. But here are, like, for example, if I asked you to graph Y equals 4, why is Y equals 4 horizontal line? Because you have anything you want for X, right? If I ask you to graph X equals 5, why is it a vertical line? Because you can do whatever you want for Y. So here, if you told theta equals pi over 4, I can do whatever I want for R. There's infinite possibilities, but it'll be all those dots will form a line. So if I were to not draw a line, fine, whatever. But what's going to happen? It's going to be a bunch of dots. And when I connect all those dots, what do I form? A line. That's all that's happening. Okay. We could probably skip this part. Let's go on page 4. All right, so this is where I want you guys to kind of go on Desmos and just make some sketches and describe what's happening. So I'll kind of do the first one so you guys see what's happening. Let's close this, close this, close this. So Desmos, the beauty about Desmos, it knows when you start typing in R what to do. So if I do cosine and just type in the word theta, what did it do for me? When I graphed R equals cos theta. Not exactly. What's the center? Yeah, so here's the thing. It's the way you would describe this. So this is what you want to write your notes. You describe it like this. A circle with a diameter of 1. It passes through 0, 0. And the diameter lies on the polar axis. And the right side. Lies on the right side. So you wouldn't say the center's at point, but it's kind of weird. I mean, I guess you could say that, like, but it's in terms of polar coordinates, 0.5 comes there. I guess you could say that. But usually what we say is we want to say the physical dimensions, like, oh, the diameter is this long, okay, it passes through the pole, great, and the diameter is coinciding with the right side of the polar axis. Polar axis, remember, is horizontal axis too. Probably
Can you just say that it's a circle
Mhm.
diameter of 1 vertices 0, 0, 1, 0?
Sorry, vertices of what?
Or
Center.
just like say the vertices are 0, 0, and 1, 0.
You can't actually. What we're going to really say though, what we're going to do down the line. We won't do this till after our test, but I'll tell you right now. We're actually going to state the symmetry. It's symmetric about theta equals 0. That's what we want to say, because theta equals 0 cuts it in half. Sometimes, like for example, what if I do this? Okay, what happened now by switching the sign?
Well, then
Pi over 2 exactly, and that's what we're really going to be working towards is symmetry here. Because if you plug in sine pi over 2, that's 1, right? Cosine of 0, of course, is 1.
so here do you want us to rank that or no?
No, not necessarily. No, it's okay. Just tell me where the diameter lies. So like, for example, for sine theta, let me move this over. And by I did put the fill up version of these notes in school just so you have access to it. So here, what if I do r equals sine theta? Ah, switch that. Here we go. So in this case, let me go and copy and paste this. For r equals sine theta, here's what I say. Diameter, same thing. Passes 0, 0. But the diameter lies on yeah, or theta equals pi over 2 above the pole. Because this is above the pole. So that's how you're describing it. Now,
For the other 4, what happens if I put 2 in front of cosine theta? The diameter increases, right? Or if I put 3 in front of sine theta, the diameter increases. What if I put a negative in front of the cosine? Reflection, so now being a negative, or left side of the 4 axis. If I do -3, it'll be below the 4, right? So go to and just try those so you can see what's happening. We'll have a generalization afterwards.
then we'll do some conversions after that. Okay, let me show the fill out notes because I'm getting lazy. Hold on. Yeah, the pole that is called the pole 0, 0. It's called the pole. So let's move to here. Yeah, so here's what's happening. Let's kind of just rest on this a little bit.
So yeah, circle diameter 2, pass through the pole, lies the polar axis. 3, again, diameter 3, pass through 0, 0, diameter lies the part of the pole. -2 is reversed, so it's on the left side of the polar axis. Here, -3 sine theta, of course, diameter still 3, pass through 0, 0, diameter lies below the pole. In general, r equals k cosine theta, or r equals k sine theta. K is going to be your diameter, the absolute value of k, by the way. You don't see your diameter is negative, right? You don't have negative physical dimensions. And if it's cosine, that's going to be the polar axis. It's course above if k is greater than 0, below if k is less than 0. If it's sine, it's theta equals pi over 2.
It's sorry, I'm going to say left or right for cosine, up or down, or above or below for sine. Those are the generalizations there.
And again, I'm just giving a lot of foundational stuff. This does get crazy. Crazy is going to happen very soon with this. But for now, we're just seeing a lot of foundational stuff. And this is something that you will have to work with in AP Calculus BC. AB, they never do polar. You will have to do calculus with this coordinate system in about a year from now.
So I have to start teaching to you because we just don't have that time to teach it to you. We're brand new coordinate system in AP Calculus BC. We got to start the process now. But it's very close to what you guys have seen already with trig. It's very analogous to what we've done with trig. Okay, questions so far? Nope. Okay. We're gonna do some conversions in a moment. The conversions are fun. I love these problems because it's kind of like a puzzle. It's not gonna be terribly obvious, but we'll put our heads together. And I promise I won't look at my answer key. I'll try to do this, even though I might remember from last year. Let me know when I can move on. No, it's actually another teacher. Her name, she retired, I think, 3 years ago. Her name was Ms. Jones. She had some kids go to school here and she retired. And so that's her handwriting. Yeah, it's very nice handwriting. It's definitely not mine, that's for sure. But she was very low tech. She didn't like to type stuff up. She always handwrote everything. Okay, can I move? Okay, up. Let's do it from scratch. Here we go. Okay, so let's talk about how to convert these. Let's look at is that right? Yeah, that's what I do. Okay. So we know what r equals 2 cos theta. We know it's a circle now. We know r equals -3 sin theta is a circle. Let's prove it. So what if I multiply both sides by r? What would happen? I get r squared equals 2r cos theta. What does r squared equal in terms of x and y? X squared plus y squared, we know that already now, right? We established that earlier on. What does r cos theta equal? Just x. Yep. Because on a unit circle, we assume r is 1, but really it's still r in general. So x squared minus 2x plus y squared equals 0. If I do completing the square, add 1, add 1. And that makes sense. That makes sense that we would see that. So we do the same thing here. Multiply r, r squared equals -3 r sine theta. So then we could say x squared plus y squared. Ugh, please. Yeah, exactly. It's not a fun one, but it's all right, we'll do it. Actually, yes. Take half and square. You're going to add 9/4 actually. Right. Very good. So you should get x squared plus y plus 3/2 squared equals 9/4. So the center is at 0, -3/2. The r squared is 9/4, which would be square root, that would be 3/2 still. So, okay. Questions? We're good? Yeah, in terms of x and y. Yeah, what you guys have been used to for pretty much most of your lives. This is a new system. Yeah, I think we could stop there for today. I mean, just really quickly to go the other direction. For example, 7, for example, I'll do this really fast. To go the other direction, I would actually say x squared minus 18x plus 81 plus y squared So this is going the other direction, right? To write in polar form now. If I, what happens to A1s? Those cancel. So you have x squared plus y squared. I'll move this over to the other side here. What's x squared plus y squared? And 18x, I could rewrite it as r cos theta. And then the r's cancel from each side. It'll be that. So these are things that we'll be working towards. You know what? I'm not giving you homework. Enjoy. Yeah, you guys got too much going. Yeah, that's okay. I don't need to take up more of your time this week. But I would say keep working on this stuff. I don't think Delta Math can be a good resource. I'll see if there's anything good there. Maybe. I'll try to put some more stuff under test review. If I find other good stuff, I'll put stuff there. Keep working on what you guys have been working on already. And then we'll just do more review on Wednesday. I'll have more details about the test by Wednesday. And then of course, we have that long weekend to study. So yeah, no problem. Yeah.
I think it makes sense. You can make, but the thing